Hello students, today I am going to discuss the chapter number 4, determinants. In the last chapter, matrices, we have learnt what were the matrices, different types of matrices, what were the different types of operations that were applied on it, means the algebra of matrices, how the matrices are added, how the matrices are subtracted, how the matrices are multiplied, how a number is multiplied to a matrices, and so on. So now in this chapter determinants, we will learn what is the concept of the determinant of a matrix. तो इस चैप्टर में हम ये सीखेंगे कि जो डिटर्मिनेंट का कंसेप्ट है वो क्या है. ठीक है, मैट्रिक्स चैप्टर में हमने सीखा था, वी हैव लर्न्ड दैट इफ द सिस्टम ऑफ लिनियर इक्वेशन a1x plus b1y equal to c1 and a2x plus b2y equal to c2. These are the two equations. So we have a system of linear equation in two variable, a1x plus b1y equal to c1 and a2x plus b2y equal to c2. So this system of linear equation can be expressed in terms of matrix like a1, b1, a2, b2, and in other matrix we can write the variables xy, and the constant c1 and c2 can be written in the third matrix c1, c2 like this. So simply you see that if these two matrices are multiplied to each other, then we will have this relation a1x plus b1y, that's equal to c1, and a2x plus b2y equal to c2. Means the system of equations can be expressed in terms of matrices. So now let's suppose that this is the matrix A and this is the matrix X and this is the matrix B. So the given linear equations can be expressed in terms of matrix as AX equal to B. Clear? Now in class 10th we have learnt that if the two equations are given, a1x plus b1y equal to c1 and a2x plus b2y equal to c2, then if a1 upon a2 is not equal to b1 upon b2, then unique solution will exist. So here we see that it can be written as a1 b2 minus a2 b1, that is not equal to 0. So here a1 b2 minus a2 b1 is the number that determines the uniqueness of the solution of the equations associated with the matrix A. Is it clear? So we have understood that the number a1 b2 minus a2 b1, that is not equal to 0. This number a1 b2 minus a2 b1 determines the uniqueness of the solution. So it is written as determinant A, or this determinant A equal to a1 b1 a2 b2, and its value is a1 b2 minus a2 b1. So the number a1 b2 minus a2 b1 will determine the nature of the solution of the equation. So it is called the determinant of A matrix. Means dat A, it is the determinant symbol, it is not the modular sign. So determinant of A matrix is determinant A, and it is represented as this. Between the two bars the numbers have been written here. Means a1 b1 a2 b2, and its value is a1 b2 minus a2 b1. Determinants are widely used in the field of engineering as well in economics, social science and science. There is an important point that you should note, that a square matrix can have the determinants only. मतलब जो भी मैट्रिक्स स्क्वायर मैट्रिक्स हैं उनके डिटर्मिनेंट्स पॉसिबल हैं. क्लियर? फॉर एग्जांपल मेरे पास एक लिनियर इक्वेशन है in single variable. So if we have a equation with a single variable, then it can be solved. But if we have linear equation in two variable, then one equation is not sufficient to solve it. एक equation से solve नहीं हो सकता. Suppose 2x plus 3y equal to 7 is given, then we can't get the unique solution, because in this case x and y will have infinite solutions. So 2x plus 3y is a single equation, but it is having two variables. If there are two variables, then we must have two equations to solve. Means if we have 3x minus 4y equal to 5, then these two equations can be solved. Means if two variables are there, then two equations are compulsory. So in this way, here we see that there are two equations. So A matrix will be A1 B1 A2 B2, that will be a square matrix. Now suppose there is third variable also, means the equation is suppose A1x plus B1y plus C1z equal to D1 and A2x plus B2y plus C2z equal to D2. This way these two equations are there, but the variables are 3. So we cannot solve these two equations. We need another third equation. So suppose the equation is A3x plus B3y plus C3z equal to D3. Now it can be solved. So now you see that the matrix A will be obtained, that will be A1 B1 C1, A2 B2 C2 and A3 B3 C3. That is again a square matrix.